Hello everyone, welcome back. Today we are going to see data modeling in Power BI, how that can be done and why it is very important for our report development. So let's get started. So we also see a few functions today in DAX which is specific to data modeling, which is very useful in our real-time reporting. So let's see what is this. So basically we have four different type of relationships in Power BI. One is one-to-one, one-to-many, many-to-one and many-to-many. So we were discussing about there is something called dimensions and facts. So one side table is called dimension table or primary key table or lookup table. Many side table is called fact table or foreign key table. In database terms, we call as primary key and foreign keys. In data warehouse terms, we call it as dimension and fact. That's the only difference. But how it works in relational database and how it works in data warehousing, both are same. I mean, the terminology. But again we have multiple facts like factless fact table. Again dimensions we have like role playing dimensions, degenerate dimensions. There are many dimensions as well. And but in general the Power BI works best for star schema. So we have majorly two different type of data warehousing concepts in general where industry follows, which is star schema and snowflake schema. So snowflake schema we have highly normalized, where star schema is not highly normalized and it is good for analysis. So that's why Power BI recommends star schema modeling for our reporting. So star schema is nothing but we have a central fact table where dimensions are connected to the fact table. So each dimension will be connected to the fact table and it will be in the star kind of shape. That's why it's called a star schema. So we'll see how that looks and how that can be done in Power BI. And also there is something called single directional filter and bidirectional filters in Power BI data modeling. We will also see those in action. So before going into that, so let me show you like how different ways we can do reporting with help of data. So as we already know, we can take data from multiple sources. So even out of the multiple sources, for example, let's say your company is working with Excel. So let's say they have very big Excel with the multiple rows and multiple columns. It's a big table, which is a big fat table. It's a very big table. So everything will be in just in one table. We can directly load that table to Power BI and we can do reporting. That is one way. But this is not recommended for the performance of reports. That is why we generally split the tables into respective dimensions and facts for the proper reporting model. So let's say, for example, let's understand one small business. Let's say someone is running a business and that person have business in multiple places. It can be a world or it can be one small town, whatever it is. So now he wants to, let's understand how the business works. So it can be any kind of business, guys. I'm just giving an example here. Let's say a person, he has some business and he has to see how his business is growing and how the performance is. Let's say he's selling something. He is doing some business, which is he's selling. And for that, he's appointed few salespersons to sell those goods. Let's say it is salesperson or employee, whatever we call. Now this person sell to a customer. Like us, we purchase something from these customers. Again, these customers can be from multiple regions. One can be from India, one can be from Japan, one can be from some other place as well. And these customers who are from multiple countries and can also have different branches. Let's say, for example, in India, there are multiple branches again for this customer, for this business. Similarly, in Japan, they have multiple branches. And let's say he's because he's selling something, he has to store somewhere the warehouse. For example, the goods should be stored somewhere to distribute to the different locations and also different branches accordingly. So for that, he has to maintain some warehouse. That is, warehouse is data warehouse is just data. We call in technical terms. Warehouse is general term where we can use for some storage purpose. Again, he's the same company, the same person is also maintaining some customer care department to have some queries assigned, if some have any customers reporting some queries or answering their questions about the like availability of products, everything. let's say we have something called customer care, and this is a small set of business. I'm just giving some example. So now this person has to see overall way how his business is performing, and he has to rely on something called database where we store data. So in that scenario, how the tables would be. So this can be similar or even more different as well, but in general I'm telling. So we have, so as we discussed about, let's say we have for this location. Location is one dimension where we have all the locations where business is operating, and we have employees. Who are all the employees working in the organization? We have employee dimension table. I mean, location dimension means location ID and the location name. Similarly, it will be the data like that. Employee will be employee name, employee ID, when he joined, what is date of birth, some details specific to employee. And similarly, we have stores. In this location, what kind of stores we have? Maybe in the location we have multiple stores. One location have 10 stores, or branches in other case. We have branches. This can be one table. So like this, there are many tables. Again, few will have customer table, because who are the customers purchased from this person. Customer table we have. Like this, based on the business, we will store the data in multiple tables across the database with the different dimension tables and fact tables. I mean, that is data warehousing. So before going to data warehousing, how that works and all, so we have something called OLTP, which is online transaction processing, which is a real time. There is something called OLAP. We call OLTP and OLAP. This is for analysis. So for real time day-to-day activities, let's say my database we are using is SQL Server or Oracle or any relation database I'm using for my data storage. So the front end guy, whoever is working on a system, if you try to save something from the system, let's say for example, this guy is taking orders online, and if someone is going to take orders online, if he or she click on submit button after entering all the details, that will store in database. That is a backend database we call. It is real time OLTP, or online transaction processing. So day-to-day transactions, everything will store here. So from OLTP, in generally what we'll do is we do something called ETL in between, and we load all the transactions of day-to-day transactions into OLAP for analysis. Again, OLAP is historical analysis, like for example, how the business is performing in the last year compared to previous years, and how are my business growing compared to previous years or previous months or previous quarters. We can do many analysis here. Which salesperson is getting more revenue to the organization, and also which location is generating more sales and which location has less sales, and what are the profits and loss we got in the different regions. There are many metrics we can derive out of this small data. Like this, if you imagine there is a very big organization deals with much more business, then we can understand how much metrics we can derive out of it, and what are the metrics that business is looking to see specific to their data. So OLAP will have ETL. So there are many tools like Talent, Informatica, Data Stage, SSIS. There are many tools in the market where we use extract this data from OLTP and do some transformations inside before loading to OLAP, and we load that into OLAP system. So here we have historical data. OLAP contains historical data right from the start of the business till today. And there are many scenarios called SCD, which is slowly changing dimension, SCD1, SCD2. Usually for most of the cases we follow SCD type 2, one of the historical, we store historical data with the help of SCD type 2. This is like an ETL concept. So usually from OLTP, the actual transaction database, with the help of ETL, we load data to OLAP, which is for analysis, which is called data warehouse we maintain. So in general, we can load data from OLTP directly and connect it to Power BI for real-time reporting, or we can also connect data from OLAP to Power BI for historical reporting. We can do both. So in general, if someone is connected to OLTP for reporting, we usually go with the direct query reports. Again, depends on whether they want to see real-time data or just day-to-day transactions. That also depends. And for OLAP, we go with import or direct query. Again, that depends on how they want to see. But OLAP will be data will be like 1 day delay. Usually today after business hours, ETL will be there will be some jobs inside the ETL. From the jobs, data will get loaded from OLTP to OLTP. That is why it will be delay. So for transactions, real-time transactions, they want to see mainly using direct query report directly to the OLTP databases. For import mode, I mean, this also works with import mode, OLTP also, but in general, this is how the approach would be. Now, with this business, we have all these tables: location, employee table, branches, customer table, and with all these tables in place, we also have something called fact table. So here, what we'll have is, now here we have dimensions. One is location dimension, customer dimension, and employee dimension. There are many dimensions we have based on the business. Now these will be connected to the fact table. So here we have relations between each table. I mean, these tables relation with this table. For example, here we have location name and location ID. Here will be location ID. Again, here you have customer ID. Here we have employee ID. So this table will be referring to the main tables, and which is dimension tables, with the help of IDs, which is we call as foreign keys in general terminology of databases. So we'll have a key which is FK, which is specific, which will be in this table, which is referring to PK in this table, primary key. Now, because here we are using location ID 1, 2, 3, 4, something like that, to get the location ID, like which is 1, which is 2, which is 3, which is 4, we refer back to the dimension table. That is called, we call lookup tables. In other words, dimension tables are called lookup tables. So this is how the setup would be, like where dimensions are connected to the fact tables. And for slicing and dicing, this is the general terminology we use in reporting. Slicing and dicing means dragging, and based on the different dimensions, we just slice the data. We just filter the data and see the records accordingly. So in general terminology, wherever you go, this is the general star schema design, where you have central fact table and connected with dimensions across in the modeling. The same approach we are going to use in our Power BI as well. So this can be done. This is the actual approach. And as I told earlier, we also have one big table. Like say I have Excel where we have all the 20 columns with thousands of rows. We can also load it to Power BI and we can do reporting, but that will cost the performance. So performance will be very slow. Sometimes that is why it is not recommended to go with the very big flat table. There are some uses as well with that small, with that single table. But again, the best approach is going with splitting the table into dimensions and facts accordingly. Even though the Excel table, whichever you are using, don't have any dimensions, we can split accordingly with the help of DAX. We can also do that. So let's see in action, like what are these tables and how can we relate to this databases. Everything we'll see in action now. So I have Power BI desktop. So let me load data from Excel. Now let's see the same financial sheet we have. So here understand what business this Excel has, like what data this Excel has. So till now we are just dragging and dropping some data, but we didn't really understand what exactly the data in that Excel sheet and how that can be used for the business implications on top of the data. So by the name itself, it is financial sample. So here we have some financial data inside the Excel sheet. And with this Excel sheet, we can see the data and understand, like any kind of business, we have same kind of understanding should be there. For the main thing for reporting is we should know proper business, like what exactly your company is doing, and also we should know clearly what is data. Without proper data knowledge and without proper business knowledge, we cannot create reports properly, because if we want to do some calculation on based on the data, we should know clearly like what exactly the business and what exactly the data is telling to us. So based on that, that will be very helpful if you understand data clearly before we proceed with calculations. Now data got loaded. So this table is just a single table, single Excel sheet where we have many columns and we have rows. So here we can see there is some categories, countries, product, discount band, manufacturing price. Again, it is a sales table, it is a financial table. So it is showing country wise and different products, what are the sales and what is the profit of that, when it was sold, like date, and what is the month. This is the data we have. So because they are just a single table, so what we can do is, so we know I want to see sales by country. So what we can do is we can take some visual here and we can just drag the country to the value section and we can see the profit. Like this we can do, because it is just single table. So here we can just play around like whatever the data you want here, and we can just drag and drop and see. We can present to business. Again, while doing reporting, how you want to represent visuals, that also depends on many factors. Let's say before doing the reporting, we'll also sit with the business, understand like how they want to visualize, because everyone has their own ideas. So as a developer, you should also have some visual, some kind of visualization to want to represent in the Power BI. But business may accept that sometimes they have their own visualizations and they want to see the data in some different way. Accordingly, we'll proceed. I mean, either again, it depends on agreement. Like if they agree with what you're presenting, that's fine. If they want something new or something more out of the data, the insights what they're expecting, we can also do that based on the data we have. Now here we have just one table, and we can just drag and drop and do something like this. But now let me take data from SQL Server. So here also I'll just compare the SQL Server relations with the Power BI relations as well. So that's why it will be very easy for you, even though if you are new to databases and all. But it is recommended to learn databases first. I mean, at least not databases, at least some relations and how the data works and how data will be stored in the databases. Everything that will be helpful for your understanding even more better. So now I am taking data from my SQL Server database. So it can be anything. The tool, as I have SQL Server, I am taking from this one. So I have two databases, movies and Northwind. So let's take some tables from here: actor, cast table, country table, certificate table, director table, film table, language, studio. These are the tables I have. So this is again film database. So in this database, we have different films acted by different actors across the world. This is a small database. Now I'm loading here. Now here, so if you remembered in the very first session, I have told about the options and settings. So in the option settings, we have some options called automatically detect relationships between the tables. That is one of the options. So what will happen is, so first it will go database. So let me open SQL Server and show how that is related first between the tables and all. Then the same thing will be detected by Power BI as well. So if you see now, I think data has loaded. Now if you see here, few tables have no lines between those, and few tables have lines between them. So this is because if you go to file, options and settings, options, if you go to the report settings, I think that is the option, I believe. So go to report settings. Now for the specific file, we have something called data load. You can see import relationships from data sources for on first load. This is because of this is checked. Because of that, by default, whenever we load data to Power BI desktop, this will automatically load relationships as well. That is why you see here there is something called lines. So what are these lines? That we will discuss. So this is one model. So this third tab is completely talking about data model. So whether it can be one single table, we can do reporting, or multiple tables relationship. Generally data modeling, if you describe data modeling, connecting or relating multiple tables with the help of relations, that's called data model. We just model the data for our reporting purpose. Now here you see, you can easily understand. So one side table, this is called dimensions, and many side table is called fact table. Now what this database is telling to us is, we have country dimension, director dimension, language dimension, studio dimension, and certificate dimension. Now if I go to database, I think it's taking time to load the database. So just if you understand what is this data, so here this database contains data about some films. So these films will be in this table. Like for example, if you see, if I hover on this or this line, it is showing country ID, film country ID. If I hover on this, it is showing studio ID, studio ID. Same certificate, the specific, the same example what I've explained here. This will be linked to the keys. Keys means the primary key, foreign key. So this is our dimension. This table holds country information. This table holds director information. This table holds language information. And this is because of the films table. in the film table, while data is loaded to film table, that will be related to these tables. So now if we want to drag, if we want to see like, let's say we have, I don't know, English language only will be the primary here. If some other language, okay, let's take country. I want to see films by country. In that case, I have to drag country name, and also I have to take the count of the films. Let's say I have 100 different films in the database. To see by country level, I have to first count those films 100, then I have to slice accordingly by the country. Let's say for like India have 10 films, or Japan have 15 films, or US has 20 films. That is how this works. So if there is no relationship between the tables, that will not happen, because based on relationships only, the dimension will pass a filter. This is called, we call a filter propagation in Power BI terminology. We call filter propagation. This is single directional filter. If we have double arrow marks, we can see here that is called bidirectional filter. Anyway, we'll come to the bidirectional as well. So now by default, if you load some data to Power BI, if you allow to detect relationships by Power BI by default, this will have some lines in between this. These is called relations in general. So if you see the same relationships in database, that is again relationship. We also call that also relationships, but that is primary key and foreign key. I have this one. Let me connect to my database. So here, if I do select stars from a table or select columns from a table, we can get the data. So if you someone like very new databases, we have something called joins. We call joins in the table. So joins means like taking data from multiple tables is called with the help of joins. We have again left join, outer join, inner join. We have again outer join, we have left outer join, right outer join, full outer join, cross join. We have many joins available in databases. But in general, by default in Power BI, it is outer join. So it means, again, if I explain everything, it will be again sequence of topics. So what is left join? What is right join? What is inner join? What is the cross join? Please read about those things. But in general, Power BI is the default is outer join. Now I'm continuing to my database. So here I can write something. Let's say I want to see countries and films. So in the same example, now here it is automatically detect the relationships. Now let's say for example, if the option was turned off in the options settings, means you're not detecting relationships automatically. So this will be helpful if you have smaller tables or less tables in database to import to Power BI. If I have more than 10-15 tables, in that case what happens is the relations will be very clumsy. We cannot even understand which table has relationships and which table has not relationships. That is why it is sometimes many people, what they will do is they will just turn off that option, and they can manually drag and drop relationships in the tables. So how we can do that is, so let me delete this relationship. Now I have this films and country. I want to see what are the films by country. A simple example. Let's start with a simple example. Now here, if I go to the reporting, so I know films is a table. This is a film table. So in Power BI, we have, let me introduce some DAX formulas here as well. We have something called count rows function. So if you're similar to, it will be similar to SQL again. So we have something called select count of star from TVL film. This is the query we write to extract the count of data, count of table. So we have 260 records. Similarly, in Power BI, we have something called, if you click on new measure, there are many functions in Power BI. So these are the very frequently used in general for reporting. Let's say I want to say total film. That is the name. So total films is equal to, there is a syntax of DAX. There is something called count rows. So you can see if I type count, I have count A, count X, count blank, count. There are many functions available, but not everyone will use all the functions. There are hundreds of functions in DAX, but not everyone use all the functions in the real time. So at least if we are familiar with the frequently used functions in Power BI, that is more than enough, because it's everything. It's a learning process, because not everyone is expert in DAX. So DAX is something which is continuous learning. So if something I'm working in a new scenario today, if there is no some DAX function which I'm aware of, I should learn that and do. If something which I'm already aware, yeah, I can do right away. That is why DAX is something, even though you are expertise in Power BI for many years, DAX will, if someone will be expertise in DAX based on their experience and based on their implementation of formulas in the real-time projects, then only we can able to get even more DAX with the help of practice only. Because these are the options. Home, insert, modeling will be there at any point of time. But because of the business logic or business requirements based on the DAX formulas will vary, and how we implement will vary. That is why DAX is a continuous learning process. So we will see few DAX functions in further sessions. But let's understand how this count rows functions. There is something called count rows, and here you can see count rows of table. It means we have to pass a table as a input for this to execute this function. So I'm using TBL films. Now if I execute this one, this is called measure. We can see if you use something called calculated symbol, that is called measures. If I drag and drop here and take it to a card visual, it is 260. Now you compare the same SQL server. I got 260 here, 260 there. Now I want to see this 260 by country. In SQL, how I write is select count of star, comma. Again, first we need to understand data. So I have a country table. Select star from TBL country. Now if I execute this, we have these many countries. Now I want to see by country how many films are there. Now we know that the film table contains country ID as well, because this is the primary key table where we have primary key here, and this will be referred to. I mean, the key in the key in the film table will refer back to country ID to extract the country names. That is the general SQL. We use joins. Now to extract the same thing, if I use select count of if I use count of star, comma, and country name from TBL film. Now because country name is coming from country table, so now I have to join the table. Film table, join TBL country on TBL film dot, because this I am referring the table. This country ID is equal to TBL country ID, and where group by function, group by country name. So in SQL Server, if you want to write to extract country-wise films out of 260, China has 4, France has 3, like this. We do like this in general. Even that applies to Oracle or any other relation databases, MySQL, PostgreSQL, anything. The SQL is same, but maybe the pattern they write maybe differs. The keywords may differ, but the idea is same. Now coming to Power BI, now I have 260. Let me take you to table. Now I want to see this by country. Now what I'll do is I'll just go here. I know it is from country table. I'll just extract country name here. Now see here, everything is 260. This is wrong, because if there is no relationship between multiple, the tables, we cannot pass filter. Now here I have passed a country filter, which is called filter context again. We call in general in Power BI terminology. We have row context and filter context. So in general, for measures, we have filter context. It means 260 is the film names. If I drag country, it will show by country. If I drag language, it will show by language. If I drag by actor, it will show by actor. That is called filter country. We pass a filter through dimensions and we can slice and dice the data. Now, because there is no relationship between these two tables, we are not seeing the proper expect output what we are expected to see. Now what I'll do is I'll just drag this country ID. There are two ways of creating relationship in Power BI. Either, okay, let me first go to the actual way. One is click on manage relationship. We can go from here, or we can directly right click on this country, the table, and we can see manage relationship. Both are same. Either you can go from here or here. Click on this and select new and select which tables you want. So I want to relate between country table and film table, and based on country ID, and here we have film country ID. I can see one too many. It means one record here is referring to multiple records here. It means one country has multiple films in this table. That is called one too many in general. Again, we have cross value direction, which is single and both. So by default it is single. We'll see why both is enabled and why this will be useful, but in general both is not recommended. We have some different approach for that. We'll see that as well. Now click on OK, which is make relationship active. Now the moment if I enable this one, because now I can pass a filter from dimension to fact. If I go to my reporting, I can see that is split between the countries. That is why relationships are very important in Power BI, and again, and a whole data modeling is important. Similarly, the other way of creating relationship is I'm deleting the same thing. Now how we can do is just hold this country ID here and drag on the film country ID here. Even this will create also the same thing. So Power BI automatically detects whether this is one side table or many side table based on the underlying data. Now even if you go to this, if you double click on this line, we can see we have 4 different things: one to one, one to many, many to many. Because the data is not like that, like others, that is why it is selected as one to many. Again, one to many to one, both are same, because based on the table's order you are selecting, that will differ. I mean, for a many side table, if you are taking data and filtering the one side table, that is many to one. From one side table, if you are taking data to a many side table, that is one to many. But in general, at any point of time, it will be one to many only. That is as per the standards. And so this is how we create relationship between multiple tables, and we can slice and dice on top of data. So I think you got some idea how this relationship plays an important role in Power BI for data modeling. So let's continue because this will keep we have to discuss even more further about this relationships and all. So I'm just pausing now. So let's continue with the next session to understand even more better about relationships and different ways we create and different ways we explore data. So thank you so much, guys. Please practice. If any questions, please post in comments, and please share to your friends and subscribe and like, and please post your comments. Thanks everyone. Bye.